Hello, class. Today we are going to look at special right triangles. What these are just right triangles that have some special things about them. There's two of them that we're going to talk about. The first one is this one. This is half of a square. And the way we are going to name this, since this is half of a square, what we're looking at is this triangle right there. All right. We're going to name it by its angles. So notice it has a 45-degree angle, another 45-degree angle, and then a right angle because it's a square, right? And so we are going to call this a 45, 45, 90 right triangle because the angles are 45 degrees, and 90 degrees. All right? Now, what we're going to do with this, we can do a couple of special things with this. And what we're going to look at mostly here is the sides. So real quickly, if side A, so we've got a triangle, we have side A, B, and C right there, right? So if side A has a length of 1, and this is half of a square, then how long is side B? Well, it's another side of the square, right? And all four sides are the same, so side B has a length of 1. Now, what about side C? Well, that's easy enough. We can do Pythagorean theorem. We can figure that out. So let's see here. So C is going to equal the square root of 1 squared plus 1 squared, right? That's A squared plus B squared. So C equals the square root of 2. All right, so there it is, square root of 2. Let's go on to this. What if, instead, all of the sides have a length of 2? Well, for my square. If A is 2, then B, well, that's just another length of my square, so that's also going to have a length of 2. What about C? Okay, well, let's see. We'll do C over here. Let's see. So that would be C is equal to the square root of, in this case, 2 squared plus 2 squared, right? Just Pythagorean theorem, all we're doing. So C is equal to the square root of, let's see, 2 squared is 4, so that would be 4 plus 4. So C is equal to the square root of 8. We do want to simplify that whenever possible. Let's see, 8 is divisible by 4 and 2. Square root of 4 is 2. Out from under the square root, that one's prime, so we're done. So we have 2 square roots of 2. All right, so 2 square roots of 2. All right, let's do it again. Let's move this down right there. And now let's see here. Let's have a side length of 3. Well, if A is 3, what's B? Still length of a square, so it's all the sides are the same. So B is also 3. And let's work out C real quick. So C is equal to the square root of, that would be 3 squared plus 3 squared. All right, let's see here. 3 squared is 9, so I have 9 plus 9, which is 18. Let's simplify that. So 18 is 9 times 2. Square root of 9 is 3. Out from under the square root, the 2 is left over. So 3 square roots of 2. Okay, so looking at this, you may have noticed a pattern, right? So that's what we're going to look at now is we're going to look at the pattern of this, because if we've got a pattern, then that's a shortcut. So here we go. If A is X, any number, don't care what it is. If A is X, can I find B and C? Well, sure. B, very easy. They're both sides of a square, right? So whatever A is, B is the same thing, isn't it? So if A is X, then B is also X. All right? What about C? Well, how do you get from A to C? Well, when A was 1, C was square root of 2. When A was 2, C was 2 square roots of 2. When A was 3, C was 3 square roots of 2. So if A is X, then C is going to be X square roots of 2. All right? Whatever A is, C is just going to be that times the square root of 2. Makes it nice and easy. So let's take a look. Let's move this down. What if B is 6? Well, if B is 6, B is X, X is also A, so if B is 6, A is also 6. That's easy enough. Well, let's see, if B is 6, B is X, and so X squared is 2, X is 6, so 6 square roots of 2. That's pretty easy. No Pythagorean theorem. Don't have to do any other kind of complicated stuff. Just there it is, right? So let's look at it a little bit more complicated. Not much. What if instead C is 9 square roots of 2? Well, C is x square roots of 2, and if x square roots of 2 is 9 square roots of 2, that x is the 9, right? Which means x for B is 9, and x for A is also 9. And there it is. That was really quick. Nice little shortcut, right? Okay. It can be a little bit weird, so let's take a look at this one. What if C is 10? Right? Not 10 square roots of 2, just 10. Well, that's a little bit more complicated, but it's not a lot. So let's take a look at that. So C is x square roots of 2, right? So what that means, we'll do this over here, is that x square roots of 2, you know what, let me get a different color there. A little bit darker, a little bit easier to see. That'll work. So what that means is that x square roots of 2 equals 10. I need to find out what x is because that's a and b, right? So I'm going to divide by the square root of 2, divide by the square root of 2, and so x is equal to 10 divided by the square root of 2, which is great. That's lovely, but it's got a problem. Problem with this is that we are not allowed to have square roots in the denominator. It's considered bad form, all right? It is technically correct, but it's like wearing white after Labor Day or plaids with stripes or something, right? It's bad form. You still got clothes on, but you don't look good. So this doesn't look good. We're going to make it look prettier. And what we're going to do is we're going to get that square root off the bottom. This is called rationalizing the denominator. And all we're going to do is we're going to multiply the top and the bottom by whatever that square root was. In this case, square root of 2. Now, when you multiply 10 times the square root of 2, all you end up with is just 10 square roots of 2. Square root of 2 times the square root of 2 is 2. It's the square root of 4. Square root of 4 is 2. So the square root times itself just basically comes out from under the square root because you're squaring a square root. And so there you go, 10 square roots of 2 over 2. This is a fraction, so we do want to simplify it if possible. 10 divided by 2 is 5. So this is 5 square roots of 2. And so that's my x. So that's my a, and my b is 5 square roots of 2. Let's do one more. All right, so 15. Not a big deal, we can do that. So let's see, same thing. So 15 is c. So 15 is my x square roots of 2. So x square roots of 2 equals 15. Again, divide by the square root of 2, divide by the square root of 2. That gives me square roots in the denominator. We do not like square roots in the denominator. It's bad form, so we got to rationalize this. We're going to multiply top and bottom by the square root of 2. All right. So 15 times the square root of 2 is just 15 times the square root of 2 over square root of 2 times square root of 2 is just 2. Again, we have a fraction. Does this simplify? No, 15 doesn't divide by 2. So our answer is 15 square roots of 2 over 2 and 15 square roots of 2 over 2. All right? So there it is. That is 45, 45, 90 right triangles. Now we're going to talk about the other one. Okay, so now let's look at the other special right triangle, which is this one here. This one, instead of being half of a square, this is half of an equilateral triangle. So we're just looking at this yellow triangle here. Notice that what this is the altitude drawn from the vertex down to the midpoint there, right? And it divides it into a right triangle because altitudes are always at a right angle. Now, the angles on this, since an equilateral triangle, all of the angles are 60 degrees. This one up here is half of that angle, so it's half of 60, so it's 30 degrees. All right? So what we're going to call this is a 30 degree, 60 degree, 90 degree right triangle, or just a 30, 60, 90 right triangle. All right? Now, let's take a look at some of these. So here we're going to have A, B, C. Notice this is not an isosceles like the other one was because it's not a 45, 45. So here we're going to have a short leg, we're going to have a short leg, a long leg, and then the hypotenuse. So that's what we're going to be looking at here. I have A as my short leg. So let's take a look. So if A has a length of 1, we need to find B and C. Well, let's see here. This was an equilateral triangle, right? And A is half the size of that equilateral triangle, half of that side. So if A is 1, the entire side would be 2. And so C is the other side of this triangle right there. And so C is 2. And now we'll do Pythagorean theorem to figure out what B is. Now in this case, B is not the hypotenuse. So we're going to have here, we will have B is the square root of C squared. So 2 squared minus A squared. So minus 1 squared. All right, so B is equal to the square root of 4 minus 1. B is equal to the square root of 3. So the square root of 3. There we go. All right, and now let's take a look at another one. What happens if A is 2? Okay, well again, A is half the side of an equilateral triangle. C is the entire side of the equilateral triangle. So if 2 is half, then C is 4. All right. So if A right there is 2, then C is the entire length, so that'd be 4. Okay. So we'll do Pythagorean theorem again. So B is equal to the square root of 4 squared minus 2 squared. All right. So let's see, 4 squared is 16, 2 squared is 4, so B is equal to the square root of 12. 12 is not prime. Let's see if we can simplify that. Let's see, 12 is divisible by 4, so square root of 4 and square root of 3. Square root of 4 is 2 out from under the square root. 3 is prime, so it's done. So I have 2 square roots of 3. So 2 square roots of 3. Alrighty, let's move that down. What if A is 3? Well, again, if A is 3, A is half the side of an equilateral triangle. C is the entire side of the equilateral triangle. So that means that 3 is half. So we're going to double that, and C is 6. And now we'll do Pythagorean theorem again. We'll just do that right here. So B is equal to the square root of 6 squared minus 3 squared. So B is equal to the square root of 36 minus 9. Let's see, that would be 27. Let's factor that, see if we can simplify. 27 is divisible by 9. 9 times 3. So we have square root of 9, which is 3, out from under the square root. Square root of 3 is prime, it's done. So I have 3 square roots of 3. And is that enough to make a pattern? And looking at this, yeah, we can get a pattern here. So here we go. What if A, the short side, is just X? Well, again, let's take a look at this. So if A was 1, B was square root of 3. If A was 2, B was 2 square roots of 3. If A was 3, B was 3 square roots of 3. So if A is X, then B is X square roots of 3. Well, if A was 1, C was 2. If A was 2, C was 4. If A was 3, C was 6. So if A is X, what do we do to get from 1 to 2, 2 to 3, 2 to 4, 4 to... I can't even talk. From 1 to 2, from 2 to 4, from 3 to 6, we just doubled it. So if X is A, then 2X is C. So if your short leg, for your hypotenuse, you're just going to take your short leg times 2. For the long leg, you can take your short leg times the square root of 3. So what if what if C is 8? You always want to find A first. You want to find that short leg before you find anything else. Well, if C is 2X, then a short leg is just 1X, so that'd be half of 8, that's 4. And if X is 4, then X square roots of 3 is 4 square roots of 3. Easy peasy, didn't have to do any working out, nothing. Nice and easy. Okay, so let's make it a little bit more complicated maybe. What if the long leg is 9 square roots of 3? Well, if the long leg is 9 square roots of 3, this is X square roots of 3, so X must be 9. And if X is 9, then my hypotenuse is just 2 times X, so that's just 2 times 9, which is 18. Again, pretty easy. All right, so let's take a look at another one here. Let's do this. What if B is 10? So the long leg is 10. We want to find the other two. Always find that short leg first. And so this is that square root of 3 thing. So let's see here. So 10 is equal to x square root of 3. So we're going to divide by the square root of 3, divide by the square root of 3. And so I have 10 divided by the square root of 3. Again, you can't have the square root in the denominator. We've got to move that up. We've got to rationalize that denominator. So what we're going to do is we're going to multiply top and bottom by the square root of 3. So 10 times the square root of 3 is 10 square roots of 3. And square root of 3 times the square root of 3 is 3. So we've got this lovely little fraction. Does it simplify? No, 10 doesn't divide by 3. So our answer is 10 square roots of 3 over 3. So that's x. That's our short leg. The hypotenuse is 2x, right? 2x. So I'm going to double x. So if I have 10 square roots of 3 over 3 and I want to double it, I'm just going to make that 20 square roots of 3 over 3. All right? So that's not too bad. The first one's a little weird, but the short leg, but the hypotenuse is nice and easy. All right, so let's move that down. We're going to do one more. What if the hypotenuse is 15? Well, same thing we did a minute ago. We will just take this. So let's see here. X square roots of 3 equals 15. We want to divide by the square root of 3. And so then we've got square root of 3 in the denominator. We don't like the square root in the denominator, so we're going to get that off. So times square root of 3 times square root of 3. And so now I have x equals 15 square roots of 3 divided by 3. Again, it's a fraction. Does 15 divide by 3? Yeah, it does. That's 5. And so I end up with 5 square roots of 3 for my short leg. I want to double that for my hypotenuse. Well, 5 square roots of 3 times 2 would be 10 square roots of 3. And there it is. And so you see, with these special right triangles, we have nice little shortcuts. If you have one side and only one side, you can find the other two. Whereas before, to do Pythagorean theorem, you had to know two sides in order to find the third. Here, if you have one side, then you can find both of the other ones. So just to recap, if you have a 45, 45, 90 right triangle, the hypotenuse is equal to the legs times the square root of 2. Legs is, of course, equal to the hypotenuse divided by the square root of 2. Can't leave square root in the denominator, so you're just going to multiply top and bottom by the square root of 2. Right? Which ends up with being hypotenuse times the square root of 2 over 2. And if it simplifies, simplify it. For a 30, 60, 90 right triangle, the hypotenuse is equal to the short leg times 2, and the long leg is equal to the short leg times the square root of 3. Hopefully you found that useful, and I will see you in the next video.